Welcome to looking over the 4.6 quiz. See, for people who are redoing it, Tuesday and Wednesday this week. So the first question was, which equation could this graph be? Well, this graph is going upwards, which means it's odd positive. The degree is odd, and the leading coefficient is positive. So when we look at the choices, the only ones that make sense, let's see, the first one is -6 positive. So that's a negative odd. So the first one would be going downhill if we were looking at it, The second one is positive even, positive odd. That's the one we want because it goes uphill. The third one is negative even, which is the one that goes down. And the last one is positive even, which would be going uphill. So it's option 2. All right. The second one says find all the solutions. I would start this by looking at the factors of the factors of 20. So for instance, plus and minus 1, 2, 4, 5, 10, and 20. The way to narrow things down even more is by using a graph. So this graph on the right is a graph of that function, and we can see that it's got different solutions and different zeros at these places. Let's see, there's one at 4, there's 2 at -1, and there's one at -5. So without actually doing any work at all, I could just, like I can mark off -5 and +4 and -1. Now, if you wanted to really do it the right way, is you'd take that information from Desmos and you'd use synthetic division to double check and make sure you're not missing any. And we'll have to do with that on the next one, that's for sure. So for instance, I'm going to do -5. I'll go through with -5 and see that it does this properly. Positive 20, 0. There's a 0. Then I'm going to try -1. I'm going to put -1 in there. 1, -1, -3, +3, -4, +4, 0. And I could either factor the rest or I could keep on going. If you're not quite sure, if you don't realize that there's two answers at -1, you could try +4 and see what happens. 1, 4, 1, 4, 0. And this represents 1x plus 1 equals 0. It means that there's a second answer at -1, like I told you it was. Because it bounces or it changes direction at -1, it's going to do that. So those are the answers: -5, -1, and 4. I didn't actually ask for you to identify double roots on this assignment or this quiz. Find all the solutions that didn't use decimals. So on this one, again, what we're going to do is we're going to start by graphing it. Because that's so easy. Start by graphing it and see if you get any answers that are nice. Like, okay. What I'm telling by this then is that it looks as though -1 and +4 are solutions, and there are another two answers that are real, but they are going to be not going to be rational. So let's see. 1, -9, 18, 12, and -16. We're going to go through with -1 and see 1, -1, -10, +10, 28. We got -28, -16, and +16. All right, and +4, which gives us 1, 4, -6, -24, 4, 16, 0. And that leaves us with x squared minus 6x plus 4. So we're going to get our last two answers by doing the quadratic formula. We're going to perform the quadratic formula on x squared minus 6x plus 4. So that would be the opposite of 6, which is +6, plus and minus. -6 squared is 36, minus 4 times a times c, which is 16, all over 2 times 1. Well, this would be 6 plus and minus the square of 20, all over 2. But of course, 20 breaks down to 2 radical 5. So 6 goes into both 6 and 2, so the final answer is 3 plus and minus the square root of 5 over 1. So our answers are -1, +4, and both 3 plus and minus the square root of 5. And that's what I would expect to see. Of course, if you're doing it on a piece of paper and uploading it, it wouldn't be all over the page like I just did mine, but I'd expect to see all that work at some point, unless you did it another way. You might have done it by just looking at the factors of 16, 1, 2, 4, 8, 16, positive and negative, and you could come up with it with that graph. But you'd have to use a quadratic formula or completing the square or something to get those last two answers, 3 plus and minus the square root of 5. The last two involve finding answers that are finding polynomial answers based on what's given. So for instance, determine a polynomial function of least degree with leading coefficient of 1 and integer coefficients with the following roots. The first thing to know is that this rational, if it's going to have integer coefficients, then the conjugate is also going to be one of the answers. So we're going to change those roots into factors. -6 becomes x plus 6. 2 minus square root of 7 becomes x minus, parentheses, 2 minus 7, and its conjugate 2 plus square root of 7 inside there. First thing I do is I get rid of the parentheses. I have x minus 2 plus the square root of 7 and x minus 2 minus the square root of 7. Now, I would recommend you might want to think about using a big box with this thing. I don't think I need to do the whole big box. But if I was, remember that if you're going to do the whole big box, that these boxes over here end up canceling out. So you end up with something like this. So you have x squared minus 2x minus 2x plus 4, which is the perfect square. And then negative square root of 7 times positive square root of 7 is -7. Our like terms fall this way and this way. So I have x plus 6 times, what do we have over here? X squared minus 4x, and 4 minus 7 is -3. Now that's a good start. Then we would multiply those two together. What I noticed about those two is that the last terms get 6 times -3, which is -18. So this one might be an answer. I can't tell what number 4 is without erasing everything, so I guess I have to go through and do it. You could do this in a 2x3 box if that's the way you work. And you'd see what the final answer would be if it ends up being option 3 or not. Here's the x cubed and the -18. That's for certain. And we have 6x squared and -4x squared, which is 2x squared. Okay, so I'm thinking we're seeing a trend here. -24x and -3x, that's our -27. So it's option 3 without even looking at option 4. So notice that on option 3 that this is a polynomial and its answers are -6 and 2 plus and minus square root of 7. We're just going backwards from the work we were doing before. Yeah, this last one wasn't even a good choice because the coefficients are square roots, not integers. And the last one is very similar to that, except this time we're using conjugates. It's the same question. We have integer coefficients. So that means that -6i, the conjugate of +6i, is also one of our answers. So x minus 1 and x minus 2, and then we have x minus 6i and x plus 6i. When we multiply the first two together, we get x squared minus 3x plus 2. And the second two, you're going to get x squared. The middle terms are going to add up to 0, of course. You have -6 times +6 is -36. I times it is I squared. So this ends up being x squared plus 36. And we're going to multiply those two together. So that would be just like what we were doing before. I can write it big over here. Let's see. So we have x squared plus 36, x squared minus 3x plus 2. And we'd have x to the 4th, and this is 72 over here. 36x squared and positive 2x squared are log terms. This is -3x to the 3rd, and this is -108x. So the only like terms we have are the x squareds. So our answer is x to the fourth minus 3x to the third plus 38x squared minus 108x plus 72. That polynomial that has these four answers. Okay, so that's how the quiz works, and the retake is very similar. It's not a whole lot of mystery here. This is what you should be able to do from the end of chapter 4.